Why are tires black? Today we're going to answer a question you may have never asked yourself, but one that has a fascinating explanation rooted in engineering and material science. Look at any car, motorcycle, truck, or even an airplane. What do all these machines have in common besides wheels? Tires. And what color are they? Almost always black. But have you ever stopped to wonder why tires are black? It's not just about style or appearance. In fact, the black color of tires is one of the greatest secrets behind their durability, performance, and most importantly, safety. It is a key element that transforms natural rubber, which is not even black to begin with, into a strong and resilient material capable of withstanding extreme conditions. But if natural rubber is not black, why did tires become black over time? What is the magic ingredient that gives them their dark color while dramatically improving the properties of rubber? To answer this, we need to go back in time and understand a little about the history of tires and rubber itself. In the early days of the automotive industry, when the first cars began appearing on the roads, tires were made almost entirely from natural rubber. And natural rubber, as it comes from rubber trees, usually has a milky white, yellowish, or beige color. That means the very first tires were actually light-colored, close to the original tone of raw rubber. If you look at old photographs of vintage cars, you'll notice that some of them really did have white tires. However, pure rubber had a serious problem. It was not very durable. It wore out quickly, degraded under sunlight and heat, and lacked the strength needed for increasingly demanding vehicles. Early tires only lasted a short number of miles before failing. Engineers and chemists soon began experimenting with additives to improve rubber performance. And what was the revolutionary additive that changed the history of tires and turned them black? The answer is carbon black. Introduced into tire manufacturing around 1910, carbon black is a very fine powder made primarily from carbon, produced through the incomplete combustion of heavy petroleum products. It is not simply a dye or paint. Instead, it becomes part of the rubber structure itself. But how can carbon black, which is basically just a black powder, transform rubber so dramatically? The answer lies in the multiple ways it improves the material. First, carbon black acts as a reinforcing agent. It creates chemical bonds with the polymer chains in rubber, making the tire far more resistant to abrasion and wear. It is almost as if it creates a microscopic reinforcing network inside the rubber, increasing its strength and durability. Without carbon black, a tire would only last a fraction of the time modern tires do today. Second, carbon black helps dissipate heat. Tires generate enormous amounts of heat while driving because of constant friction with the road and the repeated flexing of the rubber. Excessive heat weakens rubber and accelerates its deterioration. Carbon black absorbs and spreads this heat throughout the tire structure, preventing dangerous hot spots from forming. This greatly extends a tire's lifespan and helps maintain performance even at high operating temperatures. In addition, carbon black provides excellent protection against ultraviolet radiation from the sun. UV light is one of rubber's biggest enemies because it causes molecular degradation, making the material brittle and less flexible over time. Carbon black acts like a powerful sunscreen, absorbing UV rays and shielding the rubber molecules from damage. Without this protection, tires would crack and deteriorate rapidly under sunlight exposure. Tires made without carbon black would have a drastically shorter lifespan if exposed to the sun for long periods. So it is the combination of all these factors, structural reinforcement, heat dissipation, and UV protection, that makes carbon black an essential component in modern tires. Experts estimate that carbon black can increase the lifespan of a tire by up to 10 times compared to pure natural rubber. This enormous improvement in durability and performance made it the industry standard, turning black into the universal color of tires around the world. But what if someone wants tires in other colors? Is it possible to make tires that are not black? Technically, yes. Over the years, we have seen white wall tires, where only the sidewalls were white, as well as colored tires used on bicycles, show cars, and custom vehicles. To create these colors, manufacturers replace carbon black with other reinforcing materials or pigments, such as silica. While silica can also strengthen rubber, it does not provide all the same benefits as carbon black, especially when it comes to UV protection and heat management. It is also generally more expensive. As a result, colored tires tend to be less durable, more costly, or have compromised performance compared to standard black tires. Another interesting fact is that modern tire engineering is far more advanced than most people imagine. Tires are not made from a single type of rubber. Instead, they are composed of multiple layers and specialized compounds designed for different functions. Some layers maximize grip, others improve flexibility, and others provide strength and puncture resistance. Carbon black plays a critical role in many of these layers, helping manufacturers balance performance, longevity, fuel efficiency, and safety. The importance of tires is often underestimated because they are such a common part of everyday life. Yet they are the only part of a vehicle that actually touches the road. A small contact patch, sometimes no larger than the palm of your hand, is responsible for accelerating, braking, and steering thousands of pounds of metal at high speeds. That means tire reliability is absolutely critical. The introduction of carbon black more than a century ago revolutionized transportation by making tires tougher, safer, and more dependable. Without it, modern vehicles as we know them would not exist. Today, researchers continue exploring new tire technologies. Others are experimenting with airless tires and advanced synthetic rubbers that could further improve durability and efficiency. So the next time you look at a car, motorcycle, truck, or airplane tire, remember that its black color is not just for appearance. Behind every black tire there is an incredible story of chemistry, physics, and material science working together to keep the world moving.